In the last video, we were given values for initial velocity, something along the lines of 56i plus 56j was one of them. In this case, we're told the initial speed is u with an angle alpha to the horizontal from a point on the horizontal plane. So the initial velocity here is going to be u cos alpha times I plus u sin alpha times j. And if we apply our formula to this, we're going to get v of x. Just going to write the u plus at. So v of x is equal to u cos alpha. And s of x is equal to ut plus a half at squared. So s of x is equal to u cos alpha times t. Now, in this question, it's the example from the book where they tell you the greatest height and the range. So we're just going to calculate them using these formulas and we'll get the same answer. So let's look at v of y. It's going to be u again plus at. A in these cases is equal to minus g. So minus 9.8. So v of y is equal to u sine, just let me rub that out, sine alpha minus gt, and s of y is going to be u sine alpha times t, this ut over here on the right, and half at squared is going to be minus gt squared divided by 2, or you could write this as a half gt squared. Either one is fine. And we're asked to find the greatest height. So we know that the velocity of y is equal to 0 at this greatest height. So if we apply that to height, we're looking for the displacement s. So v squared is equal to u squared plus 2as. This s will give me the height. So when the velocity of y is equal to 0, at this point here, the greatest height, we can say that 0 squared, or just 0 if you want, is equal to the initial velocity, which is this u sine alpha. So u sine alpha to be squared, and we're going to have, now it's going to be 2 by a, so that's minus 2 gs. You could say that s is equal to this h, this height, but I'm just going to leave it as s. They have h in the book. So we just need to simplify this and get s on its own. So 0 is equal to, when we factorize a product, both of them square. When we square a product, both of them square. So u squared sine squared alpha minus 2gs. So you can probably see what s is here, but I'm just going to do it the long way. 2gs is equal to u squared sine squared alpha. So s is equal to u squared sine squared alpha over 2g. And we were asked to show that h is equal to u squared sine squared alpha over 2g. So therefore, that's what h is. And we could write quod erat demonstrandum at the end, that which must be demonstrated or proven. So to find the range, we need obviously the time taken to get here. This is my s of x. So let's find the time taken when at this point from before, you know that the displacement in y is 0. So here's my displacement in y. So I'm just going to write it out again. U squared. Now I could bring the minus across immediately and multiply across by 2, and you could definitely speed it up. But just for now, let's take a long approach to these questions. This has to be equal to 0 at this point. So u sine alpha, we're trying to solve for t here, and then we're going to sub it back into my displacement in x, which we have over here, u cos alpha times t. So we're going to have to multiply this time by u cos alpha. This is equal to gt squared over 2. So multiplying across by 2, 2u sine alpha times t is equal to gt squared. So we're going to cancel the t with the squared part. So there's going to get t on its own is 2u sine alpha divided by g. And now we need to multiply this. This is equal to time. There would also be a time of 0 in here. T could be equal to 0, but we're just going to look at the time taken to get the furthest distance. So the displacement x, u cos alpha by this s of x is equal to u cos alpha times t, which is 2u sine alpha all over g. So we're going to get this u, and this one is going to be u squared. So we've got a u squared sine alpha cos alpha. So it's 2u squared sine alpha cos alpha, or cos alpha sine alpha, divided by g. That's the displacement in x. Now, if we look at, these are my trig identities that we're going to start seeing a lot of. If we were told that the range was equal to u squared sine 2 alpha over g. So you can see here, we have our u squared, sine 2 alpha over g, and leave my 2 out, and then my 2's look like these alphas, so I'm just going to change that to an a for now, so you don't get confused with my 2's. So we have our u squared, so this 2 sine alpha cos alpha, in the tables 2 sine alpha cos alpha is equal to sine 2 alpha, which I'll just use an a here. So that's why we can say this guy is equal to sine u squared sine 2 alpha over g. So this is my range in simpler form. So these trig identities where one thing is equal to something else, we'll be using a lot in applied maths. In the last part of this example, you were asked to show the range will be a maximum if alpha is 45. Now, sine max, the maximum we can get for sine is equal to the 1, and the same as cos max, but the sine max in this case, we're going to say sine 2 alpha. To get a max here, the sine of 2a would have to be equal to 1. So the inverse sine of 1, you guys know, gives 90 degrees. So we could say that 2 alpha is equal to 90 degrees. So alpha therefore would have to be 45 degrees. So this is a little intro into sine, cos, dealing with range and dealing with the maximum height, and the angle alpha will be 45 to create a maximum range. So go over this video, take notes on it, and then move on to exercise 3b, which deals with these questions in sin and cos.